Hi friends, welcome to our channel. Let's look at problem 1128, number of equivalent domino pairs. In this video, we are going to use dictionary to address this problem. So here the main points are the following two. First is that the equivalent relation defined in this problem is rotation or permutation invariant. So once you know this point, you know how to count equivalent ingredients or equivalent members in a group, and then you need to know how to count, right? So if you look at example 2, so here 1 2 1 2 and 1 2, so these three actually are all equivalent to each other. Therefore you just need to choose 2 out of 3, that is 3, right? So here, because this has 2 in this group, so you choose 2 out of 2, so it's just 1, right? Because this 2 is just 1, so 1 group, right? So therefore, the coding will be the following. You group according to equivalent relation. Then within each group, so choose 2 out of the group size. So in the coding, you can just get the group size, right? So let me do this first. So here you have a collections, we can just use counter, right? So then we are going to iterate over dominoes. So in dominoes. First, because it's a rotation or permutation relation, so I want to use the smaller one in front and larger one in the second place as a key. So if A is greater than B, so I'm going to switch them. After this if condition, so A is always less than or equal to B. So then I'm going to use this tuple as a dictionary key. Notice that this tuple is immutable, or more precisely is hashable. Therefore, it can be used as dictionary key. So then we're going to count this, increment this by 1. Because of this initialization method, actually, if the key hasn't been accessed yet, it's going to default to be 0, right? So once you have this, you can print out this D. So for example, here is 2, right? Here is 1, and here is 1. So notice that if your group size is less than 2, right? If you still want to choose 2 out of 1, so first you will get 0. Actually, the mathematical formula also gets the same result. So now with that said, let's do the result. So here I'm going to write a for loop, but you can use comprehension. So for value or size in the values, so notice that this size can be 0 or can be 1, but can be greater than 2. Only those greater than or equal to 2 yield positive contribution. So here what we do is result increment by size times size minus 1, then integer division by 2, right, overall. So here, you know, if size is 1, this gives you 0, right? If size is 0, you also get 0. So it does not matter. In other words, we don't need this. If size is greater than or equal to 2, then you do this. It's not necessary. So I'm going to just use this. And then we just need to return the result. Let me check this return. So yeah, submit. Yeah, it passes all the cases. So here is one way, but you know, if you want to write shorter code, so you can do something like this. What you can do is return submission size times size minus 1, integer division by 2 for size in the values. So again, you don't need this. You don't need a filter like see if size is greater than or equal to 2. But adding this is also okay. I can submit that. Yeah. But if you want to delete this part, it's also good, right? Yeah. So I guess that's basically about it for the current video. As I mentioned, this is an easy problem. However, the 2 points you need to notice is that first, equivalent relation given here is rotation or permutation environment, and then you know how to count, right? So once you know this 2 points, writing the code is like translate these two steps here into coding format, right? So with that said, that's it for the current video. Thank you for watching.